Okay, good day. This is Dual Enrollment Pre-Calculus. I am Mr. McCully, and this is lesson 41 on polar coordinates. Let's get right to it. So today we are going to talk about how to plot points and find multiple representations of points in the polar coordinate system. We're going to convert points from rectangular to polar form, and then we're going to convert polar equations to rectangular equations and back. So first, let's talk about what a polar coordinate is. Now, you are used to seeing coordinates listed in x, y form. So it's almost like a tic-tac-toe system where everything to there along the x-axis is positive, and on the x-axis to the left is negative, and then up on the y-axis is positive, and down on the x-axis is negative, or on the y, excuse me, down on the y-axis is negative. And so we basically are just doing a system where we go left and right and up and down. And we order it, the x value first, then the y value second. That's how you've basically been used to expressing values in a planar system. And polar coordinates are a little bit different than that. Um, they are still expressed as an ordered pair, but they're expressed as r, a distance from the origin. So if here's my origin, then r is going to be the distance away, and then theta is going to be an angle measured from the standard position. So as just a real quick example, and I'll probably do two. Let's say I said 2 comma pi over 4, just as a simple instance. Well, I'd come out 2 units, and so it would look like this. I'd have, and I don't like that line, so let's make it a little smaller. I take this, I come out 2 units, and then I'd open up this, and again, it's the same length. That's 2 units there, but I would open up this way. Oops, I didn't mean to do that. Let's get my pen tool. And then I'd open up this way, pi over 4 units, and that's what this is. That's not a y, that's 4 with an ordered coordinate plane. Now we can also go negatively. So let's say I said something like this. Let's say I go 3 and then negative, let's go 7 pi over 6, I guess. That'll work. So I come back over here. Let's use blue this time, and let's change the line, make it a little smaller, start and end. That works. And so this time, I'm going to come out 3 units, and I'll make that mark. Keep it the same. I'll come back negatively 7 pi over 6. And so I came out 3 units. And so this distance here is 2, this distance here is 3, and this angle right here is negative 7 pi over 6. So this point right here is the coordinate 2 pi over 4, and this coordinate right here is the coordinate 3, negative 7 pi over 6. All right. Now, when we want to convert points and or functions from rectangular to polar, we understand that in rectangular form, that our coordinates, our points, are in xy form, so are our equations. They're written in xy form. And then in rectangular, our coordinates are written in r and theta form. So also our equations are written in r and theta form. So let's see what that looks like. So example, let's convert square root of 3 comma negative 1 to polar coordinates. And so again, if I'm thinking just real quick here, square root of 3, negative 1, so square root of 3 and then negative 1 would be this point right here and that line. And so I'm looking for this length here. There's my r, and I'm looking for that angle theta. So if I come back to here, and I want to convert rectangular to polar, I need to get the r value. So r is going to be square root of x squared plus y squared, and that makes sense because it's just a distance formula, and that's what I'm finding right here, the length of r. And so my r is going to be the square root of 3 squared plus negative 1 squared. And so the square root of 3 squared is 3. The square root of negative 1 squared is 1. So I get the square root of 4. So my r value is equal to 2. And then to get theta, if we go back to here, theta is equal to y over x. And so if I go, my tangent theta is y over x. So theta will be equal to the arctangent of y, negative 1 over square root of 3. Now, I think that the square root of negative 1 over 3 is going to be an angle on the unit circle. Let's see here. Is it going to be 1 over? It's going to be negative a half over square root of 3 over 2. That's going to be it. So because that'll be equal to negative a half times 2 over square root of 3, which would be negative 1/3. So I need a negative a half here. So negative a half square root of 3 over 2. Well, that's going to make that angle negative pi over 6. So the coordinates of this thing is going to be 2 negative pi over 6. That's my final answer for that one. All right, now if we want to convert the polar coordinate, 4, 11 pi over 9, well, 11 pi over 9, 4 is going to, it'll be 11 pi over 9 is a little bit bigger than pi. And so this distance right here is going to be 4, and then this angle right here will be 11 pi over 9. That doesn't come out to be a real nice value on the unit circle, so we may end up with something a little different. But we do know what x and y are going to be. It's r cosine theta and r sine theta. So let's go back here. And so x is going to be equal to 4 cosine 11 pi over 9, and y will be equal to 4 sine 11 pi over 9. And again, these aren't on the unit circle, so we'll grab our calculator here. Let's hit the mode button to make sure that we are in degree mode, and we're not. So I'll hit enter there. So quit. So I need 4 sine, let's do cosine first because that's x, cosine 11 pi divided by 9, close that parenthesis, negative 3.6064, negative 3.064. So x equals negative 3.064, and then y will equal, let's go second entry, and let's see if we can change it to sine. Maybe that'll be a little bit easier. There we go. And we get negative 2.571. Negative 2.571. And so our final answer, negative 3.064, comma, negative 2.571. And again, we use the calculator on this one because that is not on the unit circle. All right, let's talk about converting a rectangular equation to the polar form. And here we have a rectangular equation, and we're assuming that a is greater than 0. And so in this particular instance, we already know what the shape of this graph is. We've been doing conic sections, and this is a circle with radius 4, because this is r squared, if we remember. So, but if I want to convert back, if I come down, look at this, I've got an x squared plus y squared equal to r squared. Well, that's fairly easy. If I want to convert this, this thing right here is r squared equal to 16. And then r would equal to 4. And then you say, well, where's the theta part of this? Well, this just says that r is 4 units away, and that theta can be anything. Kind of like when we do y equal to 2. This thing is a horizontal line that has that's at y equal to 2. Just like this is a circle that has a radius of 4, and that's how we kind of think of it in the polar form. And so we'll leave with that. Now, this particular linear equation, or this rectangular equation, is a linear equation. It is a linear equation that has a slope of negative square root of 3. Well, if I go back to my conversions here, if I get x and y by itself, like this, x over y, I can find an angle measure. So think of it this way, with this one. This is just, this graph here is just a line that's going to end up, that's not very good, let's do a better job. It's just going to be a line that goes through the origin, all right, and that has a slope of negative square root of 3. So if we find just this angle theta here and say it's all of the points that are at that angle, we'll be good. So if I go negative square root of 3 is equal to, actually, you know what, let's do it this way. If I go y over x equals negative square root of 3, well, if I go back here, y over x is equal to tangent theta. All right, well, we can do that. And so I get y over x, that's my tangent theta equals negative square root of 3. And just like we did in the last one, negative square root of 3, this one though, if I go negative square root of 3 over 2 all over a half, well, that'll be equal to negative square root of 3 over 2 times 2 over 1, which will be negative square root of 3. And so I got to find the angle on the unit circle that has a y value of negative square root of 3.5. Well, that ends up being negative pi over 3. So this theta here is going to be negative pi over 3. When I take the arctangent of both sides, you'll get, and you can check it on your graphing calculator and it'll work. And so this thing, kind of like, again, if I were to say x equals to 3, we would have a vertical line at x equal to 3. Theta equal to negative pi over 3 in rectangular form just says any point that is on the angle that has negative pi over 3. So it gives you that line right there. And we'll put a box around it and we're done. Now, if we want to convert the polar form to rectangular form, this thing right here, this 11 pi over 6, theta equals 11 pi over 6, well, that particular angle, or well, this particular value right here, we can say is going to be a line at 11 pi over 6. So 11 pi over 6 is right here. And so if that's our theta, we can use that tangent function again, because if I'm given just theta, I can convert that into x and y. And so I'm going to say that the tangent of 11 pi over 6 is equal to, tangent 11 pi over 6 is going to be equal to y over x, and the tangent of 11 pi over 6, well, we know that at 11 pi over 6, we're pi over 6 away, so the y value will be, let's see, it'll be square root of 3 over 2, and, no, I'm sorry, that's wrong. Let's clear that out, that's a mistake. The y value at 11 pi over 6 is going to be a half, and then the x value at 11 pi over 6 is going to be square root of 3 over 2. That's going to be my y over x. And so I'm just going to simplify this thing. And so pi over 2 times 2 over the square root of 3 is going to be 1 over the square root of 3, which will be square root, and I need a negative here because the y value would be negative. So it'll be negative, that'll be negative, and then it'll be negative square root of 3 over 3. We've done that quite a bit. So just going back up here so I can finish it off, I'll get negative square root of 3 over 3 is equal to y over x. We will multiply both sides by x and bring the y back over here. So y equals negative square root of 3 over 3x. And that's going to be our answer there. All right, so this last one, let's go r equals 2 cosine theta. Well, if I go back to these equations here, and I'm trying to convert polar to rectangular, and I can say, well, r squared would be x squared and y squared, and our cosine theta would be x, and our sine theta would be y. Well, I don't have either of those per se. So I am going to, in this particular instance, I am going to multiply both sides by r. And so I'll get r squared equals 2r cosine theta. Now, why did I do that? I did that so that I could change r squared into x squared plus y squared. And I can change r cosine theta into just x. And so I was trying to manipulate that equation in a way that will allow me to make that conversion. So here's what I'm going to do. I'm going to bring this over and set it equal to 0. And so I'll have r squared minus 4, let's call it r cosine theta. That's not very good. Macaulay equal to 0. And so recall, r squared equals x squared plus y squared, and x is equal to r cosine theta. So I'm going to do the substitution to make that x squared plus y squared. And it will be minus 2. That 2 stays the same. R cosine theta is x, so 2x equal to 0. And this is a standard form of a circle. And so we'll put a box around that, and we'll call it a day. So we are finished. Today's Star Wars fun fact of the day is the fact that it took 6 people to operate the Jabba the Hutt puppet in Return of the Jedi. That's all I got, folks. Have a good day. Bye.